Hello there, we are going to talk about wet bench temperature control abnormal issue. We have two example case. Case 1. This is their HF and adding HMO3 chemical. And the process sometimes is the polysil wafer, and the polysil layer wafer processing over temperature control. We have a tank temperature here, thermocouple here, and we set the temperature at 25 degrees centigrade plus minus 2 degrees, and the oven over 27 degrees. Because this kind of chemical processing with polysil layer, if we want too much, about 5 lots above continuously. This process releases huge heat and continue to run polysil layer wafer after 5 lots above continuously running. It let the tank temperature rising over 27, and 27 above is our alarm limit. So over 27 degrees centigrade we get the alarm. But other layer without such alarm, just polysil layer wafer cause it. So going to see that because it's a low room approach to room temperature base. So it just use a simple heat exchanger to maintain its temperature. The heat exchanger is very simple. The cooling water in and cooling the chemical circular line, and then the cooling water out. Just so easy. And the heat exchanger temperature, of course, set 25 degrees as our target. So check it cooling capacity. Without that, the heat exchanger designed for low cooling capacity, so it cannot do it to control the temperature with polysilicon wafer continuously too many rounds. So the easy, soft way is set the heat exchanger temperature set point, add it to 23 degrees from original setting 25. So we set lower temperature to let just 23 degrees. Chemical to the tank and lower 2 degrees to make the tank's temperature equal to 25 degrees centigrade. This is case 1. And case 2, we have a phosphoric chemical. Phosphoric chemical is phosphoric acid with H2O water. It set process temperature 155 degrees centigrade. This is a chemical circuit line from the pump and to the filter and to the heater, then back to the inner tank. If set 155 degree, if temperature over 158 too hot, the valve A valve, this one, will open automatically to let dear water in, and dear water into the heater can lower the temperature. So temperature over 158, the A valve open automatically and to add dear water. And temperature lower 152, the heater will increase its power, use more power to heat the chemical. And it's unsteady for control because the air valve open and let too much dear water in. Too much. It let the over high temperature suddenly to decrease too much, maybe about drop to 151. The dear water too much to let the temperature dropping suddenly. Dropping suddenly and the heat increases power. Increase too much. Cause the temperature rising suddenly. So the DI water in too much suddenly drop the temperature, and the heater power increased too much to make the temperature rise suddenly too much. So we modify first of all to bypass the valve A, the original DI water in valve, and we add a regulator here, regulator R, and we add a flow meter and let the DI water in. If the temperature is too high, the regulator open and DI water in, and we have no too much DI water in each, because we already have well tuned with the regulator of the new line. This is the new line. We have the well tuned with the regulator, and through the flow meter, we saw the flow meter flow rate. We adjust the regulator for suitable DI water in flow rate. Then the temperature is over too much. The DI water in is smooth, not too much DI water. Then let the temperature down without suddenly drop very fast, so the heater power steady increase for the low temperature. So modify another new DI water in line with regulator to solve this problem. Okay, let's all see you next time.